Okay, so we're going to now solve another logarithmic equation. As I did in the last video, what we want is we want a log equal to a number or 1 log equal to 1 log. One of the two things. All right, so here what we need to do first, because this is 2 logs added, we want to use this property here. When you have the log of A plus the log of B, this is equal to the log of these two things multiplied. So this is equal to the log of x times x plus 3, x minus 3. So this is equal to that, and that's equal to 1. Well, now what do we do? Well, let me distribute the x. We have the log of x squared minus 3x equals 1. Now, because this is a log and the base is 10, I know it's not written, but remember, that's a common logarithm. It's not written, so the base is 10. Because the base is 10, we want to do 10 raised to both sides. I'll show you why in a second. If this base was 7, then you would do 7 raised to both sides. But again, this is a base 10, so we do 10 raised to the log of x squared minus 3x equals 10 raised to the first power. Why did we do that? Because of this property right here. 10 raised to the log base 10 of x squared minus 3x equals x squared minus 3x. So this is equal to x squared minus 3x. So that's the reason why, whatever that base is, you want to raise the base to the power of each side because of this property. On the right side, well, 10 to the first power is 10. This is a quadratic equation, so let me get it equal to 0, and if it factors, we would factor. If it doesn't factor, we would use the quadratic formula. So let's see. When I subtract 10, we get x squared minus 3x minus 10 is equal to 0. Does this factor? Yes, it does. It turns out our two numbers are negative 5 and positive 2. Multiply to negative 10, but these two numbers add to negative 3. We know how to solve this. We set each factor equal to 0. When I add 5, we get x equals 5. When I subtract 2, we get x equals negative 2. Now, we've got to be careful here. We want to check these. When I plug in 5, we get the log of 5 plus the log of 2 equals 1. The log of 5 and the log of 2, there's no problem there. This is a solution. But when I plug in a negative number, the log of a negative number does not exist. If you remember in an earlier video, the graph of the log looks like this. That means I can't take the log of a negative number because the graph doesn't even exist there. It doesn't exist. So the log of a negative number does not exist. So that's why you want to plug in your answers and make sure you don't get the log of a negative number. When I plug in negative 2 here, I get the log of negative 2, which is not defined. So this is not a solution. That is an extraneous solution. The only solution to this equation is x equals 5. And that is the solution, the one and only solution to this equation.